So in case you are interested in the math behind all these things, I'll be explaining most of the math we'll be doing, because the math are a bit ginormous, so I won't be able to explain everything, but I will explain as many as possible. For example, this dot product will be explained in the next tutorial in that particular series. So that's that. So v plus v, v1 plus vector 1. Mind you, the length needs to be the same. If not, might run into some problems. Then sum of x, that is sum of the variables in vector x, sort y, that is sort them numerically, the lowest first, the highest at the end. Then round, as round up all the values in vector 4, round them up to 2 significant figures. So that's what this is doing for us. So logical operators are just checking for the less than, greater than, equal to, less than or equal to, greater than or equal to. So basically, so is x less than 3, so it will check the ones that are less than 3 will be true, and the ones that are not less than 3 will be false. We actually use this a lot in programming. You will see how we use them. Then where x is equal to 3 give us true, and other places give us false. That's basically what that means. X greater than or equal to 3, so wherever x is equal to 3 or greater than 3, it will give us true. Then x less than or equal to 3 will give us true wherever x is less than or equal to 3. So random sampling now. So you want to get 5 samples from vector 4. So it will give us 5 samples from vector 4. If I run it again, it will give us a different set of numbers. So you can see this compared to this give us different set of numbers. So that's that on that. Then 10 letters, it will give us 10 different letters. If I run it again, it will give us a separate set of letters. Then we want to check for 5 samples in vector 4 with replacement. That is, when we pick a particular number, you know, normally the number is no longer part of the vector, so we shouldn't be able to pick it again. But with replacement now, it's something like you picked it, photocopied it, then put it back in the vector to be picked again randomly. So that's what with replacement, this replacement equals t does in this particular code. So that's that on that. Then we can generate random uniform generate random numbers from uniform distribution. So let me just explain that with what I have here. Okay, so from uniform distribution, this is the number of variables we want. So you write R uniform, that is random uniform, the number of variables you want, then the minimum and the maximum. So if we run that now to generate a number for us, what you notice, it generated 10 numbers between 2 and 5. So that's that. Then the next one is normal distribution. So the normal distribution is, okay, binomial distribution will first give us the number of variable, the size, and the probability. So let me just explain that to us. So basically, normal distribution, 10 variables, 5 and 2, that's the probability. No, this binomial now. So 10 numbers, the size, and the probability. In case you don't know anything about binomial distribution, check the mathematics behind these things, and I will explain each of these distributions to us. So then the normal distribution now. Normal distribution, basically we have the where is it? The normal distribution, that's the number of variables, the mean and standard deviation. So having said that, let's run this. So it generated 10 numbers with mean 5 and standard deviation 2. Then exponential distribution has just one parameter. So it will give us the number of variables and the rate. So that's that on that. So I run that. Then the Poisson distribution also has just one parameter. So it will give us the number of variables, then the mean. So that's that on that. So let's move on to the next thing. Sorry for that noise. Okay. So the next thing we want to do here is a concatenation of 1 to 10 to just give us numbers between 1 and 10. So if you check Q here, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's that. Unlike Python that will not pick the last number, this will pick the last number for you. So if you now want to slice, subset this vector now, you want to pick from position 2 to position 5. So if you slice that out for you, that's 2, 3, 4, 5. Then you might want to concatenate position 1 to position 3. So it's concatenate 1, 3, sorry. Then concatenate 1 to 3. This is what I was explaining. 1 to 3. So concatenate that for you. Then minus 4, that is Q minus 4. 1, 2, 3, 4. Okay. It removes the 4 and gives you every other thing in that particular vector. So that's that on vectors. Let's now move to matrix. So we have this vector here. We want to arrange it in 2 rows and 3 columns. So basically it does that for us. So if we don't worry, we'll print it out. And that one, 2 rows to 3 columns by row equals true. Vector 4 into 3 by 5 columns. Then this one, okay, instead of rewriting n rows and n columns, and just give it number of rows, then number of columns. So it will still do the same thing. So if we want to check for the dimensions now, you can see it's giving us the dimensions as we asked it to give us. So the dimension, the first parameter in the dimension is the number of rows. Second parameter is number of columns. So it tells us the number of rows here, then the number of columns here. Then we can do C bind and R bind. So we do this a lot when we are doing data manipulation. Probably want to bind 2 data sets together, or yes, maybe on the row or on the column. So let's just have our different vectors. So we have vector 1, Q1, Q2, Q3. They want to bind them on the columns to form, that's Q1, Q2, Q3 on the columns. If we print out, let me just print out mat 5. That's mat 5. If I run this now, oh sorry, I said R is case sensitive and my caps lock was on. Mat 5. If I print this out, you can see it bind them on the columns. If I bind them on the rows and I print out, that's mat 6. Sorry, 6. You can see it bind them on the rows instead of on the columns. So that's how to do arg bind AR. So that's that on that. Then the thing is, we want to print, okay, diagonal 4 now. So we want to create an identity matrix with 4 diagonal. So we have, sorry, let me just print out the I4 identity matrix. That is, the main diagonal we have will be 1, then every other positions will be 0. So if I print, okay, sorry, if I print out this now, you can see the main diagonals are 1 and it has 4 rows and 4 columns, and every other part of the matrix is 0. So I will explain what identity matrix means in the math behind behind statistical and statistical analysis and machine learning. So we can add 2 matrices together, just as we did in vectors. We can add 5 to each of the variables in a matrix. We can subtract a matrix from a matrix. We can subtract 5 from each of the parameters in the matrix. Then we can find the inverse of a matrix. Don't worry, I will explain how to do inverse of a matrix by hand. In the math aspect of things, we have a lot to do in the math aspect of things. So solve with solve. So when you do solve, it automatically does your inverse for you. You know, if this is an identity matrix, an identity matrix will automatically give us the same inverse. But if you do it for a different matrix, to give you a different thing entirely. So you can transpose a matrix, transpose. So that's how to transpose basically. The another thing is you can multiply a matrix by a matrix. I will explain how you multiply a matrix by a matrix in the math aspect of things. Don't worry, don't disturb your head if you don't understand how it became a 3 by 2 matrix. I will explain everything in the math aspect of things. The matrix multiplication, so that's that, and that's that. This just multiplying each of the parameters by each other rather than the normal multiplication that is element wise. So this is actually the matrix multiplication that we do, that we explain. This one is actually element wise and you understand how this one is done, but this one is what I will need to explain further to you. And in case you can try things out yourself, just try it out yourself pending the time I post that video on YouTube. So here is matrix. That's just this is what we call subsetting the matrix. So we call for position 1, first value row 1 colon 1, this row 1 colon 2, this row 2 colon 1, row 2 colon 2. So that's that on that. So row 1, give us everything in row 1, give us everything in row 2, then give us everything in colon 1, give us everything in colon 2, give us everything in colon 3. Then give us everything in colon 1 and colon 3. So that's that on that. Then now importing data into R. So the first thing we need to do is we need to know where we are working at. That's our working directory. So to get a working directory, you use get working directory in R. So probably your data is not where you are working, so you can set your working directory to wherever the data is on your system. So this is me setting my working directory to the same place I'm working right now. So now I'm importing price.csv. Don't worry, this data will be made available for you on my GitHub repo. I will comment the GitHub repo in the description section of this video. So that's that. Then that's that. We are importing CSV. That's what we call my data. Read.table. We can use read.table to import both CSV and text data. So my data.csv. So basically we can view our data here, or better still, you can just come here, my data.csv. When you press it here, it shows you your data here. So that's that on that. So my data.text, still the same data, is just I saved one as CSV and I saved one as text. So to find the mean of SQFT, square foot. So this is like the data for housing. So square foot, the price. So age of the house. So that's that. So to find the mean of the square foot of all the houses we have, the variance of the square foot, the minimum, the maximum, the median. But you can do all this with just summary. I love summary. I use summary a lot when I want to do exploratory data analysis. So that's that. Then you can plot histogram. So basically, I'm plotting the histogram of square footage. Then I'm giving this thing. I'm calling the main what's it called? The main title that will be on the plot will be this: histogram of square feet of living space. Then the color is Dodge blue. The color I want my histogram to have is Dodge blue. So you can see our histogram here. And I can have my box plot with the same parameters, but here I'm labeling then the number of bricks I want to have is 10. Then I'm labeling let me just break this down so we can have everything displayed on your screen at once, in case you are following me and coding along with me. So I want 10 bricks. We check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I want 10 bricks. So the bricks is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the bricks. Then the next thing is I want a box plot. The box plot of this data. I want the main title to be this. Then the color to be khaki, and the Y label should be square footage. So you can see khaki color. The label is here, then the main title is here. You can see here we have some outliers. Don't worry, I will explain outliers to us when the time is good to explain. So another thing with box plots, okay, we want to check for the box plot of square footage against the fourth variable in our data. That's okay. If you check our data now, the fourth one refers to, I said row by colon. So it's not we are checking this time, it is a colon. So this colon 1, colon 2, colon 3, colon 4. This colon 4 is this NE. So if we run this code, it will plot NE and SQFT. So you can see it plots the two of them. Then the other thing is, so against square feet, so I mean against NE, so we have NE to have two variables. That's 0 and 1. If you check 0 and 1, we have some that are 0, we have some that are 1. You can see some zeros here. So that's why I separated them out here. 0, 1. So that's that on that. You can do the same thing and give it a color pink. If you're a lady, you like pink, I don't like pink. Then we can give it different colors since there are two, green and yellow. So that's what we did here. So QQ plot, don't worry. This QQ plot is good for a lot of things, especially when you want to check if the data is normal. So now I want to get into loops. That's basically on condition now in